you're gonna write out the formula, okay? So always kind of start with that, just so that it kind of leads you on to where you're supposed to go, okay? So what are we doing with butane here? It's combusting, so who's reacting here? Yeah, exactly, we've got oxygen, okay? So, but butane, oh man, we gotta remember what butane is. What's butane? If you have to look, that's fine, but it's faster if you just had it memorized from last year. Yeah. Nope. Anybody? Bueller? Bueller? What is it? C4H10. Okay? So, butane, gas, plus oxygen. Okay, so what kind of a reaction is this again? This is a combustion, okay? So, combustion reaction, we want to make the most common oxides, just to refresh. Okay, so what's going to show up on the right-hand side? CO2 gas and H2O what state? Gas as well, okay? So coincidentally, the first thing that you're going to notice is that everything is a gas here, okay? So that's one of the important things of making sure that you set this equation up correctly, okay? And being able to apply this law of combining volumes, okay? So next step, we got to balance it, okay? So you guys tell me what you think should happen for the balancing, okay? So is the 10 going to mess up our hydrogen? Yeah, probably, okay? We want to try to make sure that it's an even number whenever we deal with the water vapor, because then the oxygens are not going to be a nice dividable kind of number, okay? So, when in doubt, set this up as a 2, okay? This is stuff that you guys should be doing just automatically anyways, okay? So, how many carbons do we have then? 8. So we stick an 8 in front of there, okay? How many hydrogens do we have total? 20. So how many should be here? 10. Okay, so how many total oxygens do we have now? 26. Is that divisible by 2? Yeah, man. Okay, so we can stick a 13 there. Okay, so your first step and foremost step to make sure that this works out is balancing it correctly. If not, you're completely hooped. Okay, so this is what you do next. You only have one piece of information, but according to law of combining volumes, okay, you can actually figure out how much volume is going to be produced or required by the rest of the entire equation, okay? So this is 120 milliliters. That's technically all that we need to figure all this out, because with the situations of having constant pressure and constant temperature, all we have to do is set up the ratios of how they are proportionate to each other, okay? So, for a situation like this, to figure out oxygen, okay, you're going to take the coefficient of the known or unknown value, so we're looking for oxygen, so you take it times 13, and then you work back to the information that you actually have. So, what you would do to figure out just the oxygen amount is you're taking the coefficient of the unknown value, so 120 milliliters times 13 over the original coefficient of the information that you actually are given, okay? So this is 120 milliliters times the ratio of how much oxygen is required in this particular case, divided by the amount of butane that you required, okay, in terms of the coefficient. So all you're doing is just setting up whole ratios that are being compared to each other, okay? So what volume should we get of oxygen? 780 milliliters, okay? So that's going to be required for the oxygen to fully react with this butane, okay? Now, oddly enough, we can actually solve the rest of the equation by figuring out what carbon dioxide is now, using the same idea here, okay? So we're using this one single value, but because we've balanced it, all we have to do is compare the ratios, okay? So you take the value that you originally have, you times it by the unknown coefficient, so times by 8, and then you work back to the original coefficient that you had, divide by 2. So the volume of the carbon dioxide in this question should be...
So do you have to do this for every...
Yeah. if I asked you for it, right? But like this question's only asking for the oxygen, but I'm showing you how this can apply to like all the rest of them. Same thing, okay? Okay, what about the water vapor? Okay, so what would we have to do for the water vapor? Yeah, 120 milliliters times 10 divided by 2, okay? So, the main thing that people form errors on is the fact that they will not balance their equations properly, or they'll completely forget about this topic and then not do so good on the test, okay? So this is called the law of combining volumes, okay? So we can actually figure out using these proportions to calculate